Okay, for this tutorial I will introduce how to include lights and render them in SIO2. So I'm going to resize my workspace and UV image editor, and I'm simply going to use the default Blender scene. Okay, and what we're going to do is a kind of room, okay, simple room with multiple lights that are orbiting around their origin. So I will first apply a texture here on this little cube that I'm having on my desktop somewhere. Here you go, stonewall.jpg. I'm entering edit mode and go search my stone wall here, and if I take a look in the preview, okay, there you go, my little cube, nice. And now I'm going to scale it, Control Alt and S, and I'm going to go stretch it a little here and there to create, like kind of a simple room. I'm going to just go with the original boundaries of here, the grid that we have in Blender, and staying in edit mode, I will go select the top faces, Control Alt and G, and to grab, and I'm going to then delete that face over here. Basically what we want is to have, to see the interior of this room. Okay, so basically in edit mode again, I will go and flip edit mode, select everything and flip the normals. Okay, and I'm having like the default Blender light here, and I'm going to, as a demonstration, I'm going to put it plus or minus at the center. Go back from my camera view. I'm going to push Shift and F in order to get access to the kind of first person camera mode in Blender that will help me to position my camera. And from now we're going to have a first test run. Going to go in scripting. I will rename it for tutorial 08, all good. I'm going to go search my exporter here, right click, execute script, make sure everything is selected and also that all objects are centered. Okay, that's good. And in this case, okay, important, in order to have the light, the lighting calculation that is done properly, we need to export the face vertex normals. Okay, so by default SIO2, the exporter in this version will not export the normals. Okay, so basically it's to speed up things a little. If we are not using lights, okay, if no lamp is inside your scene, it is absolutely useless to have the normals that are there. Okay, since even for the physics the normals are calculated by bullet internally, so it's absolutely useless to have it in our VBO. But in this case we do have a lamp, so I am going to toggle the normal, and I'm going to go change my output path to go in my data directory of my SDK. Okay, exporting, and nothing new here. I'm simply going to link my SIO2 with my project, and I'm going to have a first test run. Let me just verify something. Okay, because this tutorial also introduce how to render mist, in other words fog, OpenGL fog, and I simply comment that line 73 in the tutorial because first I want to just focus on the light. I'm going to compile and build and go, and then launch my simulator. Okay, so now we can see that I have a light, and this light is orbiting, and we can see that obviously things, that the faces of my room get shaded as this light is orbiting. But as we can see, it's not really precise and really accurate, and the reason why is because the OpenGL default lighting calculation, okay, is done on a per vertex basis. Okay, so in other words, the more vertex you have, the better the lighting will look like, but will obviously slow down your application on a large scale. So here what I'm going to do for my second test run, I'm going to increase my field of view to be 65. I'm going to put my end clipping plane to be like far, like at 1000, and my start clipping plane at 1.0. Shift and F to go in first person camera, okay, that you can control easily with the WASD, by the way, okay, standard kind of, Doom Quake control. Select everything again, and now this time, before exporting, I'm going to go in edit mode, select my cube, go in edit mode, and subdivide it a bit, okay. So obviously I do have more triangles here, but it's only to make sure that the lighting calculation is done properly. I will also double check that all my normals are pointing in the right direction, and they do. So we're all good to do another export. Go in scripting, make sure that we're in object mode, select everything, and this time we're going to click update and make sure that NO normals are is selected, is toggled. Export, okay, and I'm going to run that again. And now we can see that obviously the lighting calculation is a lot more precise, than our original one. Okay, you can see that now we really have, like, I'm using a lamp, so basically it's like a sphere, and we can really see that the faces, are affected. Okay, the faces of the room is more affected by this light than it was previously. Previously we got like basically like two triangles, so that was like really sort of uniform, but in this one it's like a lot better. And we're going to go one step further here, and we are going to modify, okay, before testing other property, we're going to go in, select our cube, and in material, and then first shading and then material, and we're going to change the specularity, okay, of our material, and we're going to put like an extreme color, so we're going to be able to see the change like magenta. And in addition, I will go in shaders and I will modify the hardness. Okay, basically the hardness that I'm using like in Blender basically is the shininess of the material, okay, to use OpenGL term. So basically it's a value of 0 to 511, so 512 value that I'm actually dividing by 4, so I'm able to have a range of 0 to 127, 28, okay, value, 128 value, which is the default, okay, the usual OpenGL value used for this calculation. So I'm going to go back in scripting, and I'm going to re-export, update everything, and have another test run. And now we can obviously see, okay, how the specular component is affecting, okay, in addition with the shininess. We can obviously see that it starts to be like magenta, like on the edges, okay, where the specularity like calculation comes in. So that's it for now. And now what we're going to do is we're going to add more lights, okay. The GL implementation that we are using at the moment, okay, only have okay, they confirm, okay, like give us the confirmation that a maximum of 8 lights will be accelerated, okay. More than that, more than 8 lights, we're probably going software mode and we'll slow down, like the drawings. So I'm going to modify, I'm going to keep that light here, and I'm going to duplicate the light, but this time I'm going to use Shift and D to duplicate. So basically when you're duplicating with Alt and D, okay, it's really like creating a type of instance where the materials and the properties of the object will be shared. But in this case with Shift and D, they are independent, and this